Okay, the number E. Here's how E was developed.
Oh, we did this last year. Yeah,
I don't remember this.
So the number E. Okay, no hating.
Amy's done it.
Let me know how that works out for you.
Okay.
Anybody remember the decimal approximation since you did it last year? Yeah, and it's just like pi. It's irrational, non-repeating, non-terminating. As far as we know, okay, the probability is very high that it's irrational, but I don't know. It might have been proven irrational this one, but I don't know. Anyways. Well, you could probably show that because these fractions have no common denominator, there's not going to be any repeated decimal or something of that nature. That's just a guess. I would have to look it up because I'm not that smart. So the number E is special. Okay. Why is it special? Because I said so.
Take my phone.
Okay, when calculating a table of values to graph this exponential is very special. Okay. We can use it in growth, exponential growth and decay, or we can use it in interest calculation, just like last week. So I'll show those to you. This is 1 over e squared, right? E to the negative 2,
Yeah.
which for time's sake is 0.135. Oh, that one. 1 over e. Oh, calculator. Your calculator actually has e on it, like pi. It's second divide. It has an e. Right? It's second e. So if you need to do a calculation with e in it, you can use that key. Second e. So what's 1 divided by e?
0.36.
Okay, good enough. E to the 0. Thank you for knowing that. E to the first and second, 7.7389. Okay. The graph will look like so. Hey, how about that?
Yeah, go back.
It's just e to the x kind of hits a sweet spot, and you'll see when we start working with logarithms, the inverses of these, why it's special. Okay. All right. Growth or decay? This is the equation with e in it. Okay, this is last week. This is with e in it. Okay. K is just some constant. You can get it, you'll be given it for now. Logarithms will actually allow you to solve for it. Do you need an example? So if you have an initial amount, let's say 10 people, K is 0.2 times 10 years. You can plug those in and do the calculation, right? Yes or no? I need to know.
Yeah.
Okay. There's example 1 in your book. I'm just in the interest of time. You guys took forever calculating pi. Okay, that's where it is. The do you remember the interest? Formula from last week. That's ugly. Final amount is principal 1 plus r over n to the nt. That was last week. Compounded interest. Compounded monthly or yearly or weekly or daily, whatever. Okay. With E, we can continuously compound interest, which is more beneficial to your bank account. It's better. So the interest is calculated continuously, which means the principal is added to continuously. And it gives you a higher final amount. Yeah, perfect. Principal, rate, time, with E in it. Okay. So this one, continuous. This one is some time frame where the interest is compounded. Daily, monthly, weekly, hourly, whatever. That's continuous. Usually more beneficial. Example 2 in your book gives you an example of 25 years, a $10,000 investment. The difference would be about $1,500. Okay. I wish I could give you more than that. I think you can handle it though. All right, here's 11.3. Pick one.
Pick one out of 18 to 16.
8 through 16, yeah. And I did that for a reason. So aside from assigning you one of those, they range in topics from psychology, physics, civil engineering, banking, sociology, customer service, marketing, pretty much, well, or pick one out of the ones that don't interest you.
Wait, pick one.
If you want to be an engineer, I suggest doing the engineering one.
So
Okay.
either do 1 through 7 or 8 through 16.
No. Do 1 through 7. Pick one of 8 through 16.
Thank you for explaining that, because I would have
Sometimes
just
you have
Okay.
9 or 10 or 11 or 12.
Required.
Oh!
Pick one of those.
I got it. I would have just done them all.
Just pick one. If it interests you, awesome. If none of them interest you, pick one anyways.
Pick 12.
Dude.